Web crawler is an important system design problem, but here we will be solving a coding problem. This is a very simplified version of web crawler. So given a URL, start URL and an interface HTML parser, implement a web crawler to crawl all links that are under the same hostname as start URL. So start from the page start URL. Then call HTML parser.get URLs with that URL to get all the URLs from a web page of given URL. So we'll call this get URLs method to get all the URLs present in the start URL, in the web page of the start URL. Then we'll be crawling again with those URLs. So do not crawl the same link twice. So we'll be crawling it recursively, right? So we should not call same link twice. Explore only the links that are under the same hostname as start URL. So let's see what is the same hostname means. So consider this URL http leetcode.com/problems. Here http is the protocol and leetcode.com, that is the hostname here. Consider this one http:/leetcode.com/contest. Here also the hostname is leetcode.com. Consider this too, example.org/test and example.com/abc. Here both these two URLs have different hostname. For simplicity, here we will be only crawling the URLs that have the same URL as same hostname as the start URL. Consider this example. Here we have the start URL is this one, and in the web page of this start URL we have these two links. Then with those links also we'll be again crawling, right? In this URL news.yahoo.com we have one more URL. In this web page of this link we have one more URL that also will be crawling. So basically we have this kind of looks like a graph problem. We have to traverse this, but let's see how the input is given. One more thing is, consider this one http news.google.com. If you go to this web page of this link, you will see, let's say, this two link news.yahoo.com/news.topics and news.this one, right? But if you see the hostname here is news.google.com, but hostname for this one, the links in this web page are different. So we'll not crawl these two URLs. Which graph traversal method do you think will be useful here? So this is a simplified version. We can use both DFS or BFS. But if you see in the real life scenarios, BFS is preferred over DFS for this kind of scenes, because in DFS we go deep in one path first, right? Then we explore the other paths. But in BFS we first explore all the children in the next level, then we go to the next level and so on. And it has been seen that the next level children will have more related links, right, than if you go deep in this path, right? But here in this problem we can use both BFS and DFS. So we have the URLs, these are the URLs and the ages, but these two are not given as input. So input is only this start URL, and we are having this interface, this HTML parser.get URLs. So let's say we'll be traversing. There are two ways to traverse the graph like this. One is a DFS, one is a BFS approach, right? So every time we'll be traversing, we need to get the next set of URLs, right? The links present in the web page of the current URL. So how do we get that? We'll call this HTML parser.get URLs with that current URL, and that will give me the neighbors of this URL, you can say. So first we'll see the BFS based approach, and before that we need one method to get the hostname from any URL, right? Let's see, this is the method we are writing, get hostname from any URL. And how do we get that? Consider this URL, right? If we split it by slash, what all elements we'll get? First is the http:, that is the protocol, that's the first element. Then we'll get an empty string because there are two slashes, nothing is in between. The third element or the second index element will be this leetcode.com. So that will be our hostname, right? So we can just return URL dot split slash 2. We can add the validations here because this can give the list index out of bound exception, but I'm just writing it simply. We can add the validation here. Now for BFS processing we need a queue. Let's take a collections.dq and we'll start with the start URL, right? So we can add it in my queue. Next we need a visited set to keep track of the already visited URLs so that we don't visit it again. And this set also will start with the start URL. Now we can take a different output list to return the output, but anyway in this visited set only we are adding the URLs, right? We can return that only. We can return the output in any order, so it doesn't matter here. So while queue will just get the URL, and that will be queue.popleft, right? And for next URL, in here we'll call this HTML parser to get the neighbors, but that is basically the URLs present in the web page of this current URL. Get URLs of URL if let's say the host name should be the same as the start URL, right? Get hostname of next URL is the same as the hostname of the start URL. So I have not done that. Let's do that. Hostname is get hostname of the start URL, and this one should be equals to hostname, and next URL not in visited, then only will process it again, right? So we can just add it in my visited set. And we can add it in our queue so that we can process from that URL also. We can crawl from that URL also. Okay, that's it. After this while loop runs, all the queue is empty. Now we can just return the visited. This works, and this is pretty efficient. Now let's also see the DFS based approach. It's the same. I'll just remove this part, this queue part, and we can have the visited set. We'll just remove this queue part, and we can have a DFS, recursive DFS. This is a DFS that will just take this URL, and we need the visited set, right? So every time we are processing the DFS, we can add it in my visited set. And then for is the same thing, next URL in HTML parser dot get URLs of this current URL if get host name of this next URL is same as the host name of the start URL, and our next URL not in visited, we can do the DFS on this next URL. So that's it. It's this simple. Now we have to call this DFS with the start URL and the visited set, right? I mean, in this case, we don't need to start the visited set with the start URL, because first time when we will be visiting, we can add it in our visited set. So that's it. After that, calling this DFS, our visited list set will be populated. We can return that. Okay, I missed something. Yes, this works. Let's submit this. Okay, this is also efficient. So what is the time complexity of these algorithms? So both BFS and DFS runs in order of V plus E complexity, right? So it's basically V is the number of nodes, but that is basically the number of URLs, unique URLs we have, and ages is basically the neighbors of one URL, right? So that is defined by this HTML parser call. For each URL, it is returning the next level of URLs. So yeah.